So here we're going to use de Moivre's theorem to find the fourth root of this complex number. So it's as if what we're trying to find is z, which is the fourth root of 3 minus 4j. And it's almost impossible to do that using rectangular coordinates. So what we need to do is convert this to polar coordinates. That's r and theta. So the first thing you do is draw a quick Argand diagram. That means you've got your real axis, horizontal, and your imaginary axis. And what you want to find is r, which is the length here, this magnitude, and this angle, theta. So this is r, and this angle is theta. Now, strictly speaking, the angle in polar form is measured anti-clockwise. So this angle would have to be negative. So whatever we got here would need to report as negative theta. So to find r, it would simply be the real squared plus the imaginary squared under a square root, so that's 5. And to find theta, it would be the inverse tangent of the imaginary divided by the real. And the negative sign there is because this angle is actually a clockwise angle from the real axis, whereas in polar we generally measure anti-clockwise. So that's our r and theta. So we can now rewrite this in polar form. So this is in rectangular and this is in polar. And remember that this angle is in radians. So that gives you z to the power 4. The question is asking for z, which is the fourth root. So we want the fourth root of that. So we can rewrite z, what we want is the fourth root of this. In other words, what we're trying to do is apply de Moivre's theorem, which is this, to this. Okay, so just to be clear, r here is 5 and theta is negative 0.927 and n is 4 because we're trying to find the nth root, 1 over n. So if we substitute those three numbers into de Moivre's theorem, what we're actually trying to do is find r of 5 to the power 1 over 4 times cosine theta over 4, etc. So you've got a real component and an imaginary component. Now you can simplify this by saying 2 over 4 is just half pi, and then this 5 to the power 1 over 4 with your calculator, that with your calculator, that's just simplified, that with your calculator, and that's just simplified. Now remember, k is 0, 1, 2, until n minus 1. So in our case, n is 4, so it'll be 0, 1, 2, 3. So there should be 4 values that we're trying to find. So z1, z2, z3, and z4. So if you substitute 0 in there and in there, make sure your calculator's in radians, that will give you your first value. So obviously you'd need to put this in your calculator to find the real part, and then this multiplied by this to find the imaginary part. And then you just repeat that for k equals 1, 2, and 3. So you end up with your 4 roots, z1, z2, z3, and z4, to 3 decimal places. So this is in rectangular form. You could write them in polar form, but this should be enough for this kind of question. I hope you found that helpful.